In this video, we are going to talk about transient storage in Solidity. What is a transient storage? A transient storage is reset at the end of the transaction. A transient storage is reset at the end of a transaction. Example, if you call transfer function and inside this, if you have used TSTORE and have assigned a is equal to 100, once transfer executes successfully, a will be set to 0 again. So, a transient storage in Solidity is reset at the end of the transaction. Now let us try to understand the concept of transient storage using an example. First, we will define an interface. The name of that interface is ITest. Now inside this interface, we define two functions, test and val. After this, let us define our main contract callback, from where the exact call to transient storage and test storage contract will be made. Let us try to understand what is transient storage and what are test storage. Let me define test storage contract first. So here we have test storage. It has a state variable of type unsigned integer 256. Its visibility is public and its name is val. Inside this contract, we have a test function which sets val equal to 123 and it calls message dot sender dot call with b, where b is nothing but bytes memory b is equal to empty string or empty bytes. This is test storage. Now, what is a transient storage contract? In case of transient storage, first we define the slot where the variable will be stored. Let us call that as bytes memory slot is equal to 0. First we define the slot. Now let us define the test function. From within the test function, we use assembly. What we do? Assembly, and using the EVM opcode TSTORE, we specify the slot which we have defined above and the value which we store as 321. And after this, once we have stored that value, we close the assembly loop. Then we do message dot sender dot call again with b. Here also b is nothing but empty bytes. And from within transient storage, we have a function val, which is a public view function that returns unsigned integer 256, and in this case we return the transient storage variable value. So that can be done by using a return, again assembly, TLOAD, and passing the slot. So here we have our first contract storage, and here we have transient storage. The main contract the main contract which will call both test storage and transient storage is the callback contract. Now from within callback contract, we define a function test which takes an address argument called as target. Then what we do? We call ITest of target dot test. Remember, when target is test storage, at that time the state variable value 1, 2, 3 will be the same in both test storage and callback contract. Why? Because after invoking target.test in callback contract also we have a state variable val which is then assigned to val is equal to ITest of target dot val function. When we pass in the target to be the test storage smart contract, in that time the val 1, 2, 3 is the same in test storage smart contract as well as in the callback contract. However, when we passing the target is equal to transient test storage, at that time the value or the transient storage value 321 will be rewritten to 0. However, the value 321 will be persisted in the callback contract. We will verify this in the next section. So in this section, we are going to verify what we have covered in the last section, that when we call transient storage from within the callback contract, the value should not persist, whereas if we call test storage from the callback contract, the value should persist. First of all, let us take a look at our different contracts which we are going to use. So first contract is our ITest contract. It is nothing but an interface exposing two functions, val and test. Then we have our test storage contract. In test storage contract, we have defined the test function. What it does, it stores 1, 2, 3 inside the state variable val. Then it calls message.sender, passing in an empty bytes data. Then let's take a look at test transient storage. Inside test transient storage, we have a function test. What it does, it stores the value 321 inside the transient storage, wherein we have defined the slot to be 0. And then again it calls message.sender.call, passing in an empty bytes. You may have connected the dots right now, that since we are doing message.sender.call, so these test function will be invoked from within our main contract, which is the callback contract. Now inside callback contract, we have defined an unsigned in 256 variable whose name is val. It has a fallback function. From within the fallback function, what we do? We call message.sender.val. Now remember, .val is defined inside test storage, and it is also defined inside transient, and it is also defined inside transient storage. Here it is. So let me go to callback. We will first deploy test storage contract, then transient storage, and at last callback contract. After that, we will invoke the test function, first with the address of test storage contract and second with the address of test transient storage contract. Let us go ahead. First, compile the callback contract. It is compiled. I'll compile all the contracts at once. Secondly, compile the test storage contract. And at last, compile the test transient storage contract. So all the contracts are compiled. Now I'll deploy the test storage contract first. Click on deploy. Selected contract is test storage. Click on deploy. Test storage is deployed successfully. After that, I'll deploy the test transient storage contract. Test transient storage is selected. Click on deploy. Test transient storage is deployed successfully. After that, I'll deploy our main contract, which is the callback contract. Here it is, callback contract. Click on deploy. Now callback 2 is deployed. Let us now get to the crux of transient storage. First, click on callback. Select a function to interact with. I'll click on the test function. It accepts an address parameter. First, I'll copy the address of test storage. Click on this copy icon. Now scroll back. Here we have our callback contract. Selected function is test, which accepts an address. Paste the test storage contract address. Prior to clicking on transact, let me go to test storage. Select a function. Select val. Click on call. Here the answer is 0. However, after calling test function from within the callback contract, val must be set to 123 because here inside test storage we are setting val to 123. So let me just invoke transact. The transaction has went successfully. Now if I click on, val is already selected for the test storage contract. For the test storage contract, if I click on call, the value is updated to 123. However, this value is stored in the permanent storage. This value 123 is stored in the permanent storage. Hence, it is persisted both across test storage contract and across callback contract. We have verified in the test storage contract the val is now 123. Let us verify in the callback contract also the val must be 123. If I click on val, call, here it is. This is 123. So this is normal behavior in case when you use normal storage, wherein all your state variables are stored inside Solidity contracts. Now let us see what happens when we invoke the transient storage from within the callback contract. Now again coming to callback contract, select a function. I'll select test function. Here it accepts an address parameter. Now I will use the address of transient storage contract. Let me paste that. I have pasted that address. Now I click on transact. The transaction has gone successfully. Now if I see the value of val in callback, it must be 321 because from within transient storage, what we do? We store 321 at this slot, right? And then this 321 is loaded via this function val from within the callback contract. So inside the callback contract, after storing 321 in slot 0, what it does, it calls message.sender.call with empty bytes. Since callback was the contract which invoked test function, hence inside test transient storage, message.sender is the callback contract. Hence the call came to callback's fallback function, and inside fallback function we are calling ITest message.sender. Here again message.sender is test transient storage contract. .val is nothing but test transient storage val function, and from within the val function we are loading the value of the transient storage variable which is stored at slot 0. So here val becomes 321. Let us verify that. So here I am in test storage. Here I am in callback contract. From within callback contract, select a function to interact with. Click on val, call. It has updated to 321. However, if I now check the value of val in transient storage, let me check that. It is 0. Hence we conclude that when we use transient storage and call test function, that time the value was 321, which was written successfully in this state variable for callback smart contract. However, as the transaction executed successfully, the value at this slot was reset to 0, which we can verify from here. So this is all you need to know about transient storage. I hope you would have learned something valuable. If yes, please do share, like and subscribe our channel to get more updates and to get the know-hows of how Solidity's different concepts work. Thank you.